Hello students, in this lecture we will discuss the surface to volume ratio at nanoscale. We all are surprised to have very good special properties of nanoscale. But why the materials, the system is giving such extraordinary properties at nanoscale? This is due to the large surface. In this lecture we will study about this important fact. The fact of increase surface, the effect of surface on the properties. The outline that I am following here, first we will discuss the learning outcome of the presentation, followed by student effective learning outcome. Then we will discuss the basis of classification of superconductors and how magnetic field decide this, how magnetic field can classify conductors, superconductors in the two types. We will discuss the various properties and characteristics of these superconductors, type 1 and type 2. Then we will also discuss a mixed state that is called vortex state, and in the end we will close with discussing the possible applications, exercise, and finally the references. In this unit, first we will discuss about introduction of this surface energy. Then we will discuss why surfaces are so important in the case of nanoparticles. We will discuss this term, surface to volume ratio, as most of the time we talk about this surface to volume ratio. What is surface to volume ratio and why it is important, we'll discuss here. And then in the end, we will discuss about surface energy, which is the most important part to understand nanoparticles. For this lecture, I have selected two SELOs, ability to solve problems through application of theory and practical concepts, and critical and innovative thinking skills. Such understanding about the nano size will help you to develop many new applications or can think about many innovative ideas in this direction. Take this activity before entering into subject. In this activity, on the left hand side, I have shown one big cube, a cube of dimension 4, 4 by 4 by 4. On the right hand side, there are certain small cubes. As a matter of fact, these cubes are obtained by the left hand side cube. Now these cubes are having dimension 2 by 2 by 2. Now my question is, can we create and we obtain surface area of all cubes and volume of all cubes. In this case, start with the left cube. In this cube, the surface of each can be calculated. What will be the surface of each edge, each face? Yes, it will be 16 centimeters square. And how many surfaces are there? That is 6. So 6 into 16, this will be 96 centimeters square. Now the thing is, what about volume? The volume of this cube is 4 into 4 into 4, 64. So that is there. But if you take this right hand side, then we have divided this cube into 2. Now the surface area of a small cube will be 2 into 2 means 4. And since now these are the separate out, so for each cube, small cube, the surface area will be 4 into 6, that will be 24. Now you are, how many cubes you are having? Yes, 8 cubes. So 8 cubes, the total surface is 8 into 24. 192 centimeters square. So the surface area increased from 96 to 192. On the other hand, volume is still 64. Very interesting. Your area is increasing, but the volume is same. This can also be checked here by the sense that on the left hand side only one cube is there, so only outer surface can be used. But if you divide this cube into 4, 8 another cubes, so the inner surface will also come out. So surface increased, and on the other side volume is still same. So that is the importance of this. The surface can be increased. Now just thought about nanoparticles. If somehow by using any top-down approach you divide the bulk material into small, what will happen? The volume will be same, but the surface can change enormously. If the same surface change, then the surface to volume ratio will be very high. In the case of nanoparticles. Now take another example. This is little bit extended part. In this example, first I have shown a cube of 1 centimeter length. The length we have assumed is 3 inches here for each. edge. In the second case, the area of each surface, they have taken 1.5 into 1.5 edge. In the third, 1, 1, 1. Now start with this. Suppose we have only one big cube, then the area of that each face will be 3 into 3, that is 9 inches square. But on the other side, if we increase the number of cubes, the area will also increase. In the first case, if the area of each face is 9 inches square and we have total 6 surfaces in the cube, then the area is 54 inches square. In the case of second, if you divide this big cube into two small cubes with a half edge, now the edge of each cube is 1.5, 1.5 length, 1.5 width. So by this you can cut total 8 cubes. Here the total A1 is there. In this case, this is 8, and in this case, this is 27. So if you increase the values by 1 to 8 and 27, you are bringing out surface from the inside. And so in the first case, the total surface area is 54 centimeter square. However, in the second, the total surface area is 108 inches square. Why? Because now you are using 1.5 edge. So for 1 it is 2.25. But since you are having 8 blocks now, so the total is this 2.25. If as we are having 8 blocks here, so you can do the things and you will get 108 inches square. It is double than the first. If you further reduce the size h of any cube, and now in place of 2 you create it into 3, so total 3 into 3 into 3 9, and 9 into 3 27. Now 27 blocks are there, so that value is 162. So we can conclude this here. The volume is continuous, the surface area is continuously increasing, but the important thing is volume is same. Volume is not increasing anywhere. So the surface is always increasing, but volume is not increasing. This will result in increase in surface to volume ratio. The increase in surface to volume ratio is very important for us. We will discuss in the next slides why it is so important. As we have seen in the activity, that if we have a big cube and we divided the cube into smaller cubes, then the way we divide continuously, this will result in increase in the surface, and of course the volume is same because volume of the material is same, and that is why the surface of to volume ratio increases. If we move from big molecule or big materials to small materials. This is the reason the nanostructures and nanomaterials possesses a large fraction of surface atom per unit volume. By reducing the size, now almost all the atoms moves to surface. Normally the size of the atom of any material is about 1 nanometer or something. Now if you are having a system of 10 nanometer or 50 nanometer, then it consists of several atoms. So most of the atoms are on the surface in this case. And this is the reason that the ratio of surface atom to interior atom changes dramatically if we successively divide a macroscopic body into small parts. And this change ultimately results in dramatic properties of these nanostructures. Let us take an example. Suppose we have a cube of iron and the size of cube is 1 centimeter cube. In this case, the percentage of surface atom would be only 10 to the power minus 5%, and most of the atoms reside inside the surface. On the other hand, if we divide the cube into smaller cubes with an edge of 10 nanometer, the percentage of the surface atom would increase to 10%. So you can observe this. Now 10% atom will be on the surface since you have chosen 10 nm each. If you further reduce the size of cube of iron from 10 to 1, then every atom would be on surface. And the meaning of the every atom is on the surface is now each and every atom will participate in any reaction. And obviously, if all the atoms are participating, this will result in more pronounced results, more pronounced effects in terms of sensing, detection, and many other activities. It has been shown that why the percentage of surface atom changes and affects more in the properties. If you see from right hand side to here, then as you reduce the size from 10 to the power 5 to 10 to the power 4 to 100 nm we are talking, and if you reduce the size, this will increase more atom on the surface. Initially there is no pronounced effect, but in nano range, as you move less than nano, the effect increases and they suddenly rise to less than 10. And that is why we always say whenever we are talking about nanometer range, it should be less than 100 or in most of the time less than 10. So at less than 10 up to 1, it is increasing dramatically. Now most of the atoms are participating. The main consequence is great change in the physical and chemical properties of the material, and that is very important for us. This is again shown in this figure. Then the 1 by 1 centimeter cube, one first reduced in 1 mm by 1 mm, and then in 1 nm, and all the time the reduction in size results in increase in total surface area from 6 to 60 and 60 to this 60 millions. Continuous increase in the surface. However, the volume is same. Variation of surface energy with particle size is shown here. The particle size is continuously decreasing, and this will result in continuous increase in the surface area. And of course, if surface area is more, the total H is also more, then this will result in appreciable increase in surface energy. You can see from 7.2 into the minus 5 to 560 joule per gram, or edge energy is also there. This shows that the surface increases and surface energy also increases. And that is the reason the nanoparticles are more active, and not only more active but very highly active than bulk materials. And that is why they are very useful in many sensing applications, many detection applications. You might have a question in your mind as a biotechnology students, then why cells are small and organisms are made up of cells? This answer lies in the fact that we have discussed, and the remaining we will discuss in the coming slides. The organisms are made up of cells, and cells are very small structures. And these small structures, why we would want? We want small structures to increase the surface to volume ratio of any organism. As the surface area increases, the volume stays constant. You can say here the surface area is continuously increasing, then total surface area will also increase, and volume will be same. If the volume is same, then the surface to volume ratio will increase, as we have seen here. On the next two sides, here and here, the volume is same. That is why the surface area is increasing. But in the first, we have chosen this in such a way that the volume is small and surface area is more, and that is why the surface to volume ratio of the first and third is same. This can be done. The surface to volume ratio we can keep small, higher by keeping the system made up of very small structures, as we have shown. And the same thing we do with the organism. Organisms are made up of cells, and cells have surface area large. To understand why the study of surface to volume is needed for us as a biotechnologist, we must move from the fact, we must know the fact that the cell needs to produce chemical energy via metabolism to survive, and this requires exchange of material with the environment. So the rate of metabolism is a function of mass per unit volume. The large cells need more energy to sustain essential features, and this rate of metabolism is depend on mass and per unit volume. Exchange of material is also a thing, and these two things must be counterbalance each other. As the rate of metabolism, material exchange is a function of surface area. If we have more area, then equates more material movement. So when the cell grows, the volume increases, and as the volume increases as compared to surface area, this leads to decrease in surface to volume ratio. Now the metabolic rate exceeds the rate of exchange of material, because metabolic rate depends on volume and the rate of exchange depends on surface area. And if it happens, then the cell will die, and growing cells tends to divide to remain small in order to maintain high surface to volume ratio for survival. And that is why when cell grows, it divides into a small part so that more surface will be there. And yes, that is, this gives the proof why cells divides in our system, in our biological systems. Some examples may be quoted. Cells and tissues that are specialized for gas or material exchanges increase their surface area to optimize material transfer. To increase the surface area, the cells and tissues have some structures. The intentional work done by the membranes and cell is for to control various reactions like the exchange, material exchange. Intestinal tissues of digestive tract may form a ruffled structures villi to increase the surface area of the inner lining. Alveoli within the lungs have membranous extensions called microvilli, which function to increase the total membrane surface. This shows that all the structures, all the tissues have arrangements to increase the surface area so that the surface and volume can be controlled. As a matter of fact, this is useful to understand what is happening in the biological systems so that we can develop many devices, many structures for the welfare of these biological systems. Do this exercise so that you will learn this topic well. Collect some examples as we have discussed in the previous slides where surface has been increased to keep the cell functioning active, and explain with the help of some diagrams from biological applications. Also discuss why cell division occurs with cell growth. Comment on this. Book by Mirkin on nanobiotechnology concepts and applications are given as a reference. It's the best book who explain many examples from the biotechnology. So go through with this. It is with you on LMS. Thank you and take care. In this lecture, we have connected the surface to volume ratio with the applications in biotechnology. This will help you a lot in understanding the nanotechnology and their developing their applications. Goodbye till next lecture.